Oh yeah, here we go into a pretty challenging but typical AB/BC exam free response problem that involves mean value theorem. Let's dive right into it and see what we need to do. So this says we've got a table above gives values for the function v of t, which is differentiable on the interval 0 to 12. Assume it's also continuous too on the closed interval 0 to 12 because we've got values there and there. It represents the velocity of an insect that loves flying horizontally along a number line. Okay, only that would come from this brain. Does the bug's velocity decrease at a rate of -1 meters per second squared on the above interval? Explain. To talk about if the velocity is decreasing, you're saying how is the velocity changing, the rate of velocity? So remember, we've got position, velocity, and acceleration. The acceleration is what we're actually looking for, the rate at which velocity is changing. Right? Decreasing at a rate, so velocity's rate of change. So we're really being asked, is there ever a point v prime of some t value that equals -1 on 0 is less than or equal to t is less than or equal to 12? Right? Will that ever happen? So all we need to do is we need to find a place where the average rate of change is -1, anywhere on here. And if the average rate of change, the slope of the secant line, equals -1 on any of these little intervals, then there's got to be a point in time on this entire interval such that the bug's acceleration, or the rate of velocity, decreases at -1. So we look through here and we say, where is there a slope of -1? There's actually, well, not here, -5 to -3, that would be a gain of 2, right? So we rise 2 and run 2, that's a up 1. Here we went up 3, right? And that's over 3. Ah, man, that's still a slope of 1. This we went up 4 and up 1. That's a slope of 4. Let's see, can we find any place? How about 4 to 2? Well, that's down 2. Nice. And up 2. All right, we've got our slope. So here's how you write this thing out formally. I'm going to go over this. This is a real boilerplate way of doing this problem. So bear with me as I write it out. It's important. You first start out with since the function, so since v of t is differentiable, oh yeah, love writing that word differentiable, I don't know why. It's differentiable on 0 is less than or equal to t is less than or equal to 12. And I'll put an or equal to here. And therefore also continuous. So, and therefore also continuous. And I'll abbreviate that, don't abbreviate on the A, B, or BC exam. On 0 is less than or equal to t is less than or equal to 12. And, don't worry about run-on sentences, peeps. And, now what we need to show is that there is some interval where the slope is equal to -1. Right, then the mean value theorem will take care of the rest. And, we've got v of, it looks like 8 minus v of 6 all over 8 minus 6. Is equal to, well, that'd be 2 minus 4 is -2 over 8 minus 6, which is 2, is equal to -1. So now we've guaranteed that there's an interval where the rate of change of the velocity, the average acceleration in other words, is equal to -1. Oh, and I'll go ahead and use some nice units here, meters per second squared. Here we go. Now all we have to do is do some copying. So we're going to state the mean value theorem. Write it out on the AP exam for sure, no abbreviations, none of that junk. The mean value theorem guarantees, I'm going to abbreviate that just after I said don't abbreviate. I know, hypocritical. Guarantees. Now all we have to do is basically state this. So there exists a time, and technically it would be on 6, which is less than or equal to t, which is less than or equal to 8, such that, here comes the copying, the bug's velocity decreases. The bug's velocity decreases. So fun to watch me write, right? Velocity decreases at a rate, just copy it all, of -1 meters per second squared. Boom, that's it. So we start out again first with stating that the function is differentiable and continuous on the interval. That will set us up to be able to use the mean value theorem. Then we showed that there are 2 points, that between those 2 points we have a slope of the value that we're looking for, of -1. So then the mean value theorem guarantees there exists a time on that interval, 6 to 8, which is between 0 and 12, such that the bug's velocity decreases at a rate of -1 meters per second squared. Done. There's other ways that these questions can be asked with slight alterations, like they could say, is there a place such that v prime of c equals -1? And you'd say, well, yeah, by the mean value theorem, there is such a place where v prime of c equals -1. So maybe you don't have this whole bug context. Bottom line is, this is a really good boilerplate way of answering it. I love these kinds of existence problems. The difference between this problem and intermediate value theorem, that's often a question I get. The intermediate value theorem guarantees a value happens on the same level. So for instance, if we wanted to guarantee the velocity was -4 at some point, between 0 and 2, -4 falls between those two values. We only need continuity for that. The mean value theorem guarantees one level down occurs. You're given data at velocity, you want to know about acceleration. You're guaranteeing a derivative happens on an interval. That's all this problem wrote. See you in the exercises.